ഹായ്, ഗുഡ് മോർണിംഗ് വൺസ് അഗെയിൻ. സ്റ്റാറ്റിസ്റ്റിക്സിൻ്റെ അടുത്തൊരു ചെറിയൊരു പാർട്ടായിട്ട് ഞാൻ വീണ്ടും വന്നിട്ടുണ്ട്. നമുക്കിന്നിവിടെ 2 ഡയമെൻഷൻ ഡയഗ്രങ്ങൾ നമ്മൾ നോക്കാം. നമ്മളിതിലെ 1 ഡയമെൻഷൻ ഡയഗ്രങ്ങൾ 2 എണ്ണം പറഞ്ഞിരുന്നേ അല്ലേ? അതായിരുന്നു ലൈൻ ഡയഗ്രം, ബാർ ഡയഗ്രം. ശരിയല്ലേ? ബാർ ഡയഗ്രം 4 ആയിട്ട് ഡിവൈഡ് ചെയ്തിട്ടുണ്ടെന്ന് പറഞ്ഞു. അതിൽ 2 തരത്തിലുള്ളത് പറഞ്ഞു. ഇനി കമ്പോണന്റ് പാർട്ട് ചാർട്ട് എന്ന് പറയുന്ന വേറെ ഒന്നും കാണാനുള്ളത് എൻ്റെ ഒരു ഓർമ്മ. ഞാൻ സ്ലൈഡിൽ എടുക്കട്ടെ. മൾട്ടിപ്പിൾ ബാർ ഡയഗ്രം നമ്മൾ കണ്ടതാ അല്ലേ? അതെ. പിന്നെ അടുത്ത പാർട്ടാണ് ഞാൻ പോകാൻ പോകുന്നത്. നമ്മൾ കണ്ടതാ സബ്ഡിവൈഡഡ് ബാർ ഡയഗ്രം. These diagrams are also known as component bar chart. In these diagrams, each bar represents not only the whole magnitude but also various components of which it is composed of. Component bar chart makes it possible to compare components and to compare the components with the total. What are the details? See, along with the indication of the total value, total magnitude, it gives the magnitude of the components also, hence known by the name component bar chart. അതായത് ഡിഫറെൻറ്റ് വാല്യൂസ് തമ്മിലുള്ള ടോട്ടലിലുള്ള കമ്പാരിസൺ നമുക്ക് പറ്റും. ഒപ്പം ഓരോ കമ്പോണൻറ്റും, ആ ടോട്ടൽ വാല്യൂസിൽ വരുന്ന ഓരോ കമ്പോണൻറ്റും എത്ര കൂടി കുറഞ്ഞിരിക്കണമെന്ന് നമുക്ക് പരസ്പരം കമ്പയർ ചെയ്യാൻ പറ്റും. അതാണ് ഇവിടെ ഉദ്ദേശിക്കുന്നത്. ഒരു എക്സാമ്പിൾ കണ്ടാൽ നമുക്ക് വളരെ ക്ലിയർ ആവും. യു കൺസിഡർ ദിസ് എക്സാമ്പിൾ. During 2004 and 2008, the number of students in University X are given. Represent the data by a suitable diagram. See, a tabular column is given out of these different numbers of students belonging to arts, science, law, and together with the total for 4 years, 2004, 2005, 2005, 2006, 2006, 2007, 2007, 2008 are given. And in order to represent this by a bar diagram, this is the way. See, this is a graph drawn by means of Excel. There are several softwares are there for drawing curves. Out of this, the most prominent one is Origin 8, Origin 9, etc. It's a better graphing software. Excel do the purpose. This is the diagram drawn by Excel. MS Microsoft Excel. See, as we have already seen, its maximum, the total number of students is maximum in the year 2007-2008. See, it is 48,000. It is 48,000. See, the maximum value corresponds to 48,000. Along with the total, see, total for each year is given by this point. Along with this, number of art students, commerce students and law students, they can be compared. Here see, which one is the light blue law students. Sorry, arts students, science students, law students. Later, see what to say. See, okay, it's, right. In order to compare the students of this law, students belonging to the law departments is maximum for this year 2007-8, and it is least for 2004 and 5. What I mean is this: along with the comparison between the total, we can compare the different components also, as well as different components in different years. See, art students, you compare the number of art students for 2004-5 up to this point. 18,000 around. Here it is 20,000. Here it is 26,000. Whatever it is. Anyway, this is the subdivided bar chart. Then percentage bar diagram. See, let me go to the details. Subdivided bar diagrams drawn on percentage basis are called percentage bar diagram. Here, the total length of the bars would be equal as each bar represents 100%. ഇവിടെ നമ്മൾ എല്ലാ ബാറും വരയ്ക്കുന്നത് 100%ല്ല, എല്ലാത്തിനും ഒരേ ലെങ്ത് ആയിരിക്കും, പക്ഷെ ഡിഫറെന്റ് കമ്പോണൻസിന്റെ പെർസെൻറ്റേജ് നമുക്കതിൽ നിന്ന് വ്യക്തമായിരിക്കും. You go. Each bar is subdivided according to the percentage of the components. Each bar is subdivided according to the percentage of the components that I already told you. Percentage bar diagrams are useful for making comparison of relative values. ഏതാണ് കൂടുതൽ ഏതാണ് കുറവ്, അതായത് ടോട്ടൽ നമ്പറിന്റെ കമ്പാരിസൺ അല്ല, പെർസെൻറ്റേജിന്റെ കമ്പാരിസൺ ആണ് നമുക്കിവിടെ കിട്ടുക. ഫോർ എക്സാമ്പിൾ, യു കൺസിഡർ ദിസ് പ്രോബ്ലം. Draw a percentage compound bar chart for the following data showing the total number of students in a university. The previous problem itself. For 4 years, different students belonging to arts, science and law category is given along with the total. And in order to draw the percentage bar diagram, each data to be converted into percent. ഇതെല്ലാ ഡേറ്റും പെർസെൻറ്റേജിൽ ആക്കിയാൽ മാത്രമേ എങ്ങനെ നമ്മൾ പെർസെൻറ്റേജിൽ ആക്കാം. 18,000 arts students for the year 2004-2005 number of art students is 18,000. This 18,000 out of 31,000. So what about the percentage? 18,000 by 31,000 into 100. This is the percent. And in order to draw the percentage bar diagram, you have to convert each data into percentage terms. And after that, you have to plot that percentage. See the percentage bar diagram. Here, all the data bars are of equal length. For example, it represents 100%. 100%. Out of this, different percentages of different components are shown in different colors. See, this light blue is for science students. Here 9,500. And see, for 2004 and 5, the percentage for science students is greater compared to other. See, it's very easy to compare. It is almost similar with the same the year 2005 and 6. Good idea. See, I repeat, each bar represents, or each bar is used for making comparison of relative values, and each bar is drawn according to the percentage of the components. Total should be 100. That's all. Then two-dimensional diagrams. In two-dimensional diagrams, the magnitude of a given variable is represented by the area of the diagram. In one-dimensional diagram, the length or height of the bar or line represent the magnitude of the variable. Whereas in this case, two-dimensional diagrams, the area represent the magnitude of the variable. Whereas in three-dimensional diagram, the volume represents magnitude of the variable. See here, in two-dimensional diagrams, the magnitude is represented by area of the diagram. The length and width are to be, in this case, the length and width are to be considered. Two-dimensional diagrams are also known as area diagrams or surface diagrams. Most commonly used two-dimensional diagrams are pie diagram, rectangles, squares, circles, etc. Then pie diagrams, they are also known as pie charts. Pie diagrams are used when the aggregate and their divisions are to be shown together. The aggregate is shown by circle and the divisions are by sectors of the circle. To draw a pie diagram, the various components are first expressed as percentages and then multiplied by 3.6. Why this 3.6? See, around a point there must be maximum, at the maximum 360 degree. Am I right? So in order to represent the data along a circle, you have to calculate the angle corresponding to that. I mean, is represented as sectors. Let me come to the point. Then circle is divided into sectors corresponding to the angle calculated for each component. Okay. Aggregate is shown by a circle, whereas components are represented as the segments or sectors. Let me give you an example. Draw a pie diagram showing the distribution of blood group O among different countries as shown in the table. Country, blood group. Gypsies 343 343 blood group carriers are there out of 1000. That is the way. Not 100, out of 1000. That means it's 34.3%. Anyway, Indians, Hungarians, the values for these variables are given, and the solution. For each frequency, you have to calculate the percentage first, then you have to convert it into angle of a sector. See, since 343 gypsies with the blood group O are there out of 1000, the percentage is 39.3. Okay, then this 39.3 is multiplied by 3.6 so as to get the angle of the sector in the component of the circle. So the angle is obtained 141.48, and in all the cases, just like in the case of gypsies, the percentage or the angles for Indians, Hungarians are also calculated. For Indians, the angle of the sector is calculated to be 112.68. For Hungarians, it is calculated to be 105.84. See the pie diagram. Blood group O. Gypsies, Indians. Anyway, some error is there. That is Hungarians. There some logo is there. Sorry. Anyway, you know that the situation. The dark blue is for gypsies, the light blue for Indians, and this one is for Hungarians. Then comes to pictograms. Pictograms are very popularly used in presenting statistical data. In pictograms, the data are presented by pictorial symbol. Pictures ഉപയോഗിച്ചുകൊണ്ട്. The magnitude of the variable is presented by a number of pictures. Here, comparison of data is done on the basis of number of pictures and not on the size of pictures. That means no significance is there for the size of the picture, but number of pictures is important in this case. These type of representations are usually seen in televisions, newspapers, etc. for representing a given variable, population rate, inflation rate, whatever it is. See, a typical pictograms are shown in this figure. This diagram represents the varieties of apples in a food store. There are 5 varieties: Red Delicious, Golden Delicious, Red Rome, McIntosh, Jonathan. See, one apple represents 10 apples and half of the apple represents 5 apples. And very easily one can understand which type of apple is there at this food store. See, it's maximum for Red Rome. Red Rome variety. How much will be there? 4 into 10. That means 40 apples are apples of this variety, Red Rome. And what about Jonathan? It's only 35. And the lowest variety, the lowest number, the variety having lowest number is McIntosh. Only 20 apples are there. So very easily, without any mathematical calculation, one can understand the number. Interpret the curve. Here, one thing is also there. See, the size of the diagram or of the picture has no meaning, whereas the number has the significance. Then, advantages of pictograms. It is very popular type of diagrams. They are appealing and attract public. Usually used for exhibition work since it attracts masses. Masses means large crowd, public, massive crowd or massive public. That's all. So these are the three advantages of pictograms. There are some limitations also. They cannot be easily constructed. Pictograms, for construction of pictograms, a lot of calculation and a lot of tedious work is there behind drawing the pictures. And second one is they give only an overall picture and do not give minute details. We cannot represent only the number. No, I mean, no, nothing to do with the quality of the apples for in the above in the previous example. Then people rarely draw good pictures. Whenever you draw pictures, it's very tedious or not very easy to construct good pictures. But with use of computers, makes a lot of difference in this regard. It's very easy for drawing diagrams, exactly identical diagrams. So it's very easy. Manually it is difficult, but by means of computers it's very easy. Then cartograms. Cartograms are used to present data on a geographical basis. You might have seen maps. In this monsoon season, in the TV channels there will be a weather forecast. You might have seen weather forecast. Then areas where maximum probability for raining is shown by certain colors, certain patterns, or even certain indications. Let me come across these facts. Cartograms are used to present data on a geographical basis. It is otherwise called statistical maps. The quantities of the data on the map are shown through shades, dots, colors, patterns, etc. ചിലപ്പോൾ കളർ ആയിരിക്കാം, ചിലപ്പോൾ ഡോട്ട്സ് ആയിരിക്കാം, ചിലപ്പോൾ ഷെയ്ഡുകളായിരിക്കാം, ചിലപ്പോൾ പാറ്റേൺസ് ആയിരിക്കാം, whatever it is. See, a typical cartogram is shown. See, different colors are there. This is population. It's a cartogram showing population. Dark blue shows maximum population. The value is given here. We need not bother about the value anyway. The maximum, the intense blue represents population having area where maximum population density is there, and some lighter regions are there, very very light blue having very low population. See, and several colors. How many? 5 colors are used for drawing this cartogram depending upon the intensity of the population. Okay, higher the population, higher the intensity of the color. Dark blue and it's light blue, very very light blue, low population density, high population density. That is the thing. Then importance of diagrams. Diagrams are helpful in presenting quantitative facts in a simple, clear and effective pictures. They simplify the complexity of the data. They make the data readily intelligible. They can be used for the purpose of comparison. Diagrams save much time in understanding data. Facts can be understood without much mathematical calculations. Diagrams can be used only to show a limited amount of information. They show only approximate values. How many merits are there or importance? 6 importance or uses or merits of diagrams. There are 6 in number. Then limitations. Let me continue from this case. Third one, diagrams cannot indicate simple difference in large measurements. The previous 2 are already mentioned. So already 7 demerits are there. Third one is diagrams cannot indicate simple difference in large measurements. They can be misused very easily. Diagrams need more time to construct. They are not capable of further mathematical treatment. Diagrams are generally useful for comparison purpose only. Okay, these are the limitations. And the previous one are the advantages or importance or significance of diagrams. ഇതുവരെ നമ്മൾ പറഞ്ഞിരുന്നത് ഡയഗ്രങ്ങളെ പറ്റിയായിരുന്നു. ഇനി നമ്മൾ ഗ്രാഫുകളെ പറ്റി കാണാനാണ് പോണേ. ഗ്രാഫ്സ്. What are graphs? Graphs are statistical devices which can be used for presenting frequency distributions. Sorry, not frequency, frequency distributions. Sorry, there is a spelling correction. Graphs are statistical devices which can be used for presenting frequency distributions or representing frequency distributions or representing the relation between two variables. Okay, frequency distribution represent ചെയ്യാനോ അതിനെ പ്രസന്റ് ചെയ്യാനോ അല്ലെങ്കിൽ രണ്ട് വേരിയബിൾ തമ്മിലുള്ള റിലേഷൻ പ്രസന്റ് ചെയ്യാനൊക്കെയാണ് നമ്മൾ ഗ്രാഫ്സ് ഉപയോഗിക്കുക. They are drawn on graph paper, whereas diagrams are drawn on mere paper. So scales are not at all important. But in this case, scales must be there, hence they should be drawn on graph paper. The importance of graphs. Graphs are free from mathematical calculation. On just seeing we can understand the magnitude of the variable. Second one, they are useful for comparison. They are helpful for forecasting. Third one. Then the fourth one is graphs are useful for statistical analysis. Graphs are fifth one, and the last one is graphs are more accurate and precise than diagrams. വളരെ എളുപ്പമാണ്, വളരെ ആക്യുറസി ഉണ്ടാവും, കൃത്യമായിരിക്കും, കുറിക്കുള്ളതെന്ന് പറയില്ലേ, കൃത്യമായിട്ട് റെപ്രസെന്റ് ചെയ്യാൻ നമുക്ക് സാധിക്കും. More accurate and precise than diagrams. Then general rules for constructing graphs or drawing graphs. Graphs should have proper heading. Scales must be specified. Scales കാണിക്കണമെന്ന് നമ്മൾ കൃത്യമായിട്ട് പറയുന്നുണ്ട്. Independent variable should be taken along x-axis and dependent variable along y-axis. We always draw graphs in this way. Independent variable should be along x-axis, whereas you might have the terms abscissa and ordinate. Abscissa and ordinate. X-axis and y-axis വിളിക്കുന്ന പേരാണ്. Anyway, കാര്യം മനസ്സിലായല്ലോ അല്ലേ? Then graphs are broadly classified into two types: graphs of frequency distribution, graphs of time series. ഇത് രണ്ടും നമുക്ക് കാണാൻ ഡീറ്റെയിൽ ആയിട്ട് അടുത്തതിലേക്ക് പോവാം. The most commonly used graphs for representing the frequency distribution are histogram, frequency polygon, frequency curve, then ogives. Ogives are nothing but cumulated frequency curves. Graph in cumulated downward, you might have seen cumulative frequency distributions. When these distributions are drawn as a curve, it's known as ogive. And you know there are two types of cumulative frequency curves: upward cumulative and downward cumulative. And depending on these facts, there can be two types of ogive: greater than ogive and lower than ogive, less than ogive, more than ogive. Okay, whatever it is. First one is histogram. A histogram is a graph of frequency distribution. It is a set of vertical bars whose areas are proportional to the frequencies. The variable is taken along the x-axis and frequencies are taken along the y-axis. Just like we have seen, I have already told you in a previous slide. The width of the bar will be proportional to the class interval. Good idea? It's just like bar diagram, but there will not be any gap between the diagram and different bars, and the width of the bar will be equal to the class width. A histogram is drawn without any space between the bars. It is generally represent a continuous curve. If the class intervals are uniform in the distribution, width of the bars will be the same. Okay. As long as the class intervals remain the same, width of the class intervals or width of the bars, sorry, I can say in this way, class width remains the same. If in the case of uniform class width, that means uniform class width, what does it mean? See, if the class widths are given in fixed gaps, for example 10 to 20, 20 to 30, 30 to 40, 40 to 50, this represents a uniform class width. Whereas if I represent class widths in this way, 10 to 20, 20 to 50, 50 to 100, this will not be a uniform one. Got the idea? Anyway, let me come to an example. Represent the following frequency distribution by histogram. See, say uniform frequency distribution: 10 to 15, 15 to 20, 20 to 55, and the frequencies are also given: 10 to 15, 5. See, Then whenever you draw this data into a histogram, you will get histogram in this way. See, this point represents 10, 15, 20, and these points are likewise up to 35. And 10 to 15, see the data. For the class 10 to 15, it is 5. See, 5. 15 to 20, it is 20. 20 to 25, 47. 25 to 30, 38. 30 to 35, 10. Equal width. And these bars have equal widths. Am I right? And these width bars are drawn without any gap between them. Why it is so? The frequency distribution has no gap at all. See, it's a continuous curve. 10 to 15 to the class are given in this way: 10 to 15, 15 to 20, 20 to 25, 25 to 30, 30 to 35. Good idea. എനിക്ക് തോന്നുന്നത് ഏകദേശം ഒരു 20 മിനിറ്റിനുള്ള ടോപ്പിക് ആയി എന്ന് എനിക്ക് തോന്നുന്നത്. അതുകൊണ്ട് ഞാൻ തൽക്കാലം നിർത്തട്ടെ. ബാക്കി നമുക്ക് അടുത്ത ക്ലാസ്സിൽ വെള്ളിയാഴ്ച. ഓക്കെ, അത് ആ ദിവസം നിങ്ങൾ പഠിച്ചു പോകണം. ഞാനൊരു സിമ്പിൾ എക്സാമ്പിൾ മാത്രമേ ഇതൊരു ഇൻട്രൊഡക്ടറി പാർട്ട്, അധികം ക്വസ്റ്റ്യൻസ് ഒന്നും വരാറില്ല. ഒരു എസ് എ ക്വസ്റ്റിനെ കൂടുതൽ വരാറുണ്ട്. ഡിഫറെൻറ്റ് ടൈപ്സ് ഓഫ് ഗ്രാഫ്സ് ആൻഡ് ഡയഗ്രാംസ് ഒക്കെ ക്വസ്റ്റ്യൻസ് വരാറുണ്ട്. ബാർ ഡയഗ്രാം വരയ്ക്കാനൊക്കെ ചോദിക്കാറുണ്ട്. അത്ര ഡീറ്റെയിൽ ആയിട്ടൊന്നും ചോദിക്കില്ല. അതുകൊണ്ട് ഞാനൊരു ഏകദേശം ഐഡിയ തരാനേ ഉദ്ദേശിച്ചുള്ളൂ. അത്ര ഡീറ്റെയിൽ ആയിട്ട് പ്രോബ്ലത്തിലേക്ക് ഇതിൽ പോകുന്നില്ല. ഓക്കെ, അത് ആ ദിവസം പഠിക്കുക, അല്ലെങ്കിൽ നിങ്ങൾക്ക് കാര്യങ്ങൾ ബുദ്ധിമുട്ടാവും. ഓക്കെ, താങ്ക് യു all of you. Let me stop here.